morning, everyone. This is Mrs. Padmashri from Essence College of Engineering. Today, I am going to discuss with you all about principal component analysis. So, what is this principal component analysis? If you watched my previous video lecture, I must have explained about the dimensionality reduction technique, right? Reducing the unwanted features in order to improve the performance of the algorithm, right? So, one of the method in dimensionality reduction is principal component analysis. So let's move on to this PCA. What is uh, this topic PCA tells about? Dimensionality reduction is maybe both linear and non-linear depending on the method, and this PCA comes under the linear technique. Okay, it is a linear method, principal component analysis. This method was introduced by Carl Pearson, works on the condition while the data in the higher dimensional space should be mapped to the data in the lower dimensional space. So in the machine learning algorithm, when we plot the graph, we'll be having the x-axis and y-axis and x and y variables, dependent, independent variables. These all during the introduction lecture we have discussed, right? So mapping the data has to be mapped with the higher and the lower dimensional space. So that is the main concept in PCA. It works on the condition like the variance of the data in the lower dimensional space should be maximum. Okay, already you all very familiar about what is this mean, variance, the things. Okay, so principal component analysis also comes under unsupervised machine learning algorithm that is used for dimensionality reduction in machine learning. It is a statistical process which converts the observation of correlated features into a set of linear and correlated features. So this transformation is mainly done based on the orthogonal transformations. So these new transformed features, we call it as principal components. And it is one of the popular tools used for exploratory data analysis and predictive modeling. Okay, it is a technique to draw strong patterns from the given data set by just reducing the variance. So PCA generally tries to find the lower dimensional surface to project the higher dimensional data space. It works by considering the variance of each attribute. By having the high attribute shows the good split between the classes, and hence it reduces the dimensionality. The main thing is to reduce the features, right? The variance of each attributes has to be considered, analyzed, and it has to be split into good and good. Then it has to reduce the dimensionality. Some real world application of PC or image processing, movie recommendation system, optimizing the power allocation in various communication channels. It is a feature extraction technique, the same as we already discussed. We have feature selection and feature extraction. There are two techniques, right? Selection is like we are going to select the feature, and extraction, what all the important feature we will be extracting it. So this feature comes under the feature extraction technique. It is important variable and it drops the least important variable. A PCA work algorithm is based on some mathematical concept such as dimensionality, correlation, orthogonal, eigenvectors, covariance matrix, etc. So we all familiar about what is this dimensionality. See, it is a number of features or variables present in the given data set. It is number of columns present in the data set. So if I take a student data set, the attributes in the student like name of the students and roll number of the student, address of the students or the columns. So we say that is going to be the dimensionality. So reducing the dimensionality is reducing the features, these columns, these variable, these attributes. And correlation signifies how strongly two variables are related to each other. Correlation. So how these variables or how these two features are related to each other. So the it ranges from correlation ranges from -1 to +1. -1 it occurs if variables are inversely proportional to each other, and if it is a positive +1 indicates variables are directly proportional to each other. So orthogonal defines that variables are not correlated to each other, and hence correlation between The pair of variables will always be 0. Eigenvalue, eigenvector, you must have already studied, right? If there is a square matrix M, a non-zero vector V is given, then V is said to be the eigenvector. Okay, and AV is the scalar multiple of V. Covariance matrix, the matrix containing the covariance between the pair of variables is called covariance. Why we need to understand all these things? Based on these things, we are going to form steps for PCA algorithm. First step is getting the data set. We need to take input data set and divide it into sub parts X and Y. X is training set, Y is validation. Okay. And second step will be representing data into structure. We will represent the data in the form of structure. We will represent two-dimensional matrix of independent variable. Next, third step, standardizing the data. Standardize our data set, the feature with a high variance, and more important, we'll keep it with a compared to the other features with lower variance. Okay, important feature is independent of the variance of the feature. Then we'll divide it into the data item. Hence, we will name it as the matrix Z. So, calculating the covariance of Z, covariance of Z, we will take the matrix Z and transpose it. Z transpose, Z to the power minus 1. Transpose matrix, we need to find it out, and after transpose, we'll multiply it by Z. Then the output matrix will be the covariance matrix of Z. So, by applying all these things, step 5, calculate the eigenvalues, eigenvector. Step 6, sorting the eigenvectors. Then finally, calculate the new features of principal components. These are the basic steps involved in the algorithm, PCA algorithm. So, the rest of the algorithm will be discussed in the next lecture. Thank you.